Okay, so for examples 9 and 10, we are going to find the equation of a polynomial with these given zeros. So we're essentially doing the opposite, like we're undoing what we were just doing on the last two examples. So the first thing that we're going to do, we always want to make sure that we're writing our correct notation. We are going to fill in these three zeros into the linear factors. So we're going to have x plus 1/2. And this will be x minus 0, but I'm not going to write the minus 0. And then x minus 3. And then over here, I don't want this fraction inside here, so I'm just going to multiply both sides by 2. So I'll have 2x plus 1 times x minus 3. And now I'm just going to multiply all through to make sure that I'm going to expand and combine my like terms. So I'm going to multiply these two first factors together. So we'll have 2x squared plus x times x minus 3. And now I'm just going to multiply all through. I'll have 2x cubed minus 6x squared plus x squared minus 3x. And now I'm going to combine my like terms. I have 2x cubed minus 5x squared minus 3x. And this function right here will give me these zeros above. Okay. The next one is just a little bit tricky because you have a radical in here, but let me show you how we're going to make it a little bit easier. So we'll have f of x, so we've got our two roots at 3 plus root 2 and 3 minus root 2. So we have to remember that we have to subtract away the entire root, or the entire solution. Okay. So now what I'm going to do here, instead of grouping together what I have in pink, those particular roots, I want to group together the first two terms. So I'm going to have grouped together the x minus 3, and I'm going to keep this as plus root 2. And then I'm going to group together the x and the minus 3 and minus root 2. Okay? Because what I have right now is this is my expanded form of a difference of squares. I've got the same thing in the front, same thing at the end, but opposite signs in between. So I know that when I multiply this through, I'll have the x minus 3 squared, and then the multiplication of these terms combined with the multiplication of these terms will cancel. So then I'll be left with minus the square root of 2 squared. Now, I need to remind you that this x minus 3 squared is x minus 3 times x minus 3. Okay? Some of you were forgetting this on your unit test that you recently took for me. You can't just take x squared and subtract away 3 squared. It doesn't work like that. So from this first expansion, we're going to have x squared minus 3x plus 9. And then the square root of 2 squared is just 2. So we'll have x squared minus 3x plus 9 minus 2. And this will finally combine together to make x squared minus 6x plus 7. All right. So the key here is really reorganizing your terms that you have in the first set of two factors so that your life is a little bit easier. So this is a trick that I'm showing you. You could really multiply this term to this term to this term and do it 3 times and distribute 3 times, but that just gets a little bit time consuming and a little bit too hectic. So this trick right here is really key for your success and easily and in a quicker fashion for you to solve this problem. Okay. So we kind of talked about multiplicity the other day in class. So multiplicity is when you have a repeated 0 in your polynomial function. So in this case, that k is just indicating your degree of your particular linear factor. So if your k value is odd, your graph is going to cross the axis, the x-axis in particular. And if k is even, your graph is going to touch the axis and turn back around. Okay? And this is also very important. The larger the value of k that you have, the flatter the polynomial appears to be at that x value when it either touches and turns or when it actually crosses through the axis. Okay. So on example number 11, we're going to identify the zeros of this function here, and we're going to state their multiplicities, describe their effect on the graph, meaning is it going to touch and turn, or is it going to go through the x-axis and cross it, and then we're going to sketch it below. So in y equals 4 times the quantity x minus 5 squared times the quantity x plus 2 cubed, we have degrees of 2 and 3. So when we're talking about our degree of our whole entire polynomial, we just add them together to get 5. And then if you recall, the number of turning points that we have is n minus 1. So your degree is 5, so 5 minus 1 will get us 4. And then for this quantity here, this factor x minus 5, the zero that we're going to get is 5. Its degree is 2, so that is our multiplicity. And if something has an even degree, it's going to touch the axis and turn back around. And then from the next factor, x plus 2 cubed, our 0 will be negative 2. Your multiplicity is an exponent of 3. And if something is odd, it's going to cross the x-axis. Okay. So we have an odd degree function, and we have a positive leading coefficient. So I know that when I sketch my function, I'm going to think about y equals x cubed, because that's a positive leading coefficient with an odd degree, and our function starts on the left side towards negative infinity and then keeps on increasing up towards the right towards positive infinity. So when that was a very ugly line, I apologize that you have to look at that. Okay, I'm going to sketch this out, making sure that I'm labeling my y-axis and I'm going to label my x-axis. And then I'm going to have negative 2 down here and 5 over here. So I know that I want to end up towards the right and start down to the left. Okay, so at negative 2, I'm going to have a multiplicity of 3, so that means I'm going to cross the axis. And when I cross the axis, I want to be a little bit curved. I don't want to be straight, because if it was straight here, that would be a degree of 1, because that would be a linear function going through, or a linear part of this thing right here. So I can't have a straight line. So I just want to have a little bit of a curve. And then I need to end facing up. So I know that on this side over here, I need to have a U shape touching this value where x equals 5. And I'm going to be facing up. And then what I'm going to do is just connect these two in between. I'm not really concerned about what this looks like in between. What I'm looking at is your end behavior and what it is that you're actually sketching at the particular zeros. I don't mind what's going on in between. Example number 12. We have negative 2x squared minus x minus 1 to the 4th times the quantity x plus 2 to the 5th. So our degree will be 1, 2 plus 4 is 6 plus 5 is 11. And we're going to have at most n minus 1 turning points, so 11 minus 1 is 10. And we're going to have 3 different zeros here on this x squared factor. We're going to have a 0 at 0. And then our multiplicity on there is 2. When something is an even multiplicity, it's going to turn at the x-axis. Okay. Over here, the quantity x minus 1 to the 4th, the 0 that you're going to get is 1. and that is the power of 4, so that's your multiplicity. You have 4 roots at that value of 1. And this is going to turn as well, but it's going to be flatter than our 0 happening at 0, because this is a higher multiplicity than 2. And then x plus 2 to the 5th power, your 0 will be negative 2. It's a multiplicity of 5. It's going to cross, but that's a higher degree, so it's going to be flatter at that value. So we know that we have an odd degree, and we have a negative leading coefficient, so I think about y equals negative x cubed. That's what I'm visualizing in my head, and I'm using that because I know that towards the right, towards the left, we're going to start facing negative or infinity, and then out towards the right, we're going to end facing down. Okay. So I have a 0 at 0. We have 1 here at negative 2. And we have a 0 happening at 1. Okay, so we're going to start from the left and we're going to work our way over. So at negative 2, we have a multiplicity of 5, so we're going to cross the x-axis. I want it to look like a nice curve, but at this 0, it's going to be a little bit flatter. Okay. So this is a little bit flatter than my example above. At the 0, we have a multiplicity of 2, so I know that it's going to turn here. So I'm going to come back up, and I'm going to turn right back around. And then at the 0 happening at 1, we have to turn back around as well. And this 0 here is going to be a little bit flatter than my 0 happening at 0. Because this one had a degree of 2 or a multiplicity of 2. This one has a multiplicity of 4. So it's got to be a little bit flatter than the other one. And there we go.